Last week we talked about blurring, and so I wanted to give you an example of why we blur before we do thresholding. So this is a binary quantized image. We'll go in that little deeper. Instead of each pixel in a grayscale being 0 to 255, when you quantize an image, a pixel is either on or off. In our world, on means 255, white. Off means black, 0. That's binary quantized. So each pixel is either on or off. And that's a really important way that OpenCV distinguishes an object from the background. It can't do it with grayscale because it's kind of amorphous. But when it's binary quantized, it's very discrete. It's clear. A 255 is the object and a 0 is the background. So here we applied the threshold, and there's some values which are below the threshold and they're appearing black even though they're in the object, because this has texture, right? If you look at the brightness, if you can see my cursor, the brightness here inside the object is even brighter than the background. So that's why you get holes in the object. When you blur it, it starts reducing the contrast. An ultimately blurred image is all gray. So what it's doing is reducing the brights and increasing the dims so that the pixels are more averaged. And then when you threshold it, you can see it got rid of all the holes in here. And that's particularly important because notice this, when it took this solid object and it broke it into pieces, you have little islands here. And the contour program we're going to talk about again thinks these little islands are separate objects. So blurring gets rid of all the details which might be seen as separate objects. Okay, that's an important one. So any questions on that? Why do we blur before we threshold?
It helps remove some of those smaller, I guess, objects you don't really want in your later processed image.
That's right. It removes some texture detail which might create the contour to think that they're separate objects when there's really one. So it gets rid of the texture.